Missed an episode of your favorite podcast? Choose from over a decade of content in our archives, not just the latest episode. All free at GCNlive.com.
This is your call to action. Get prepared, America. Economy, survival, energy, disasters. This is USAPrepares.com. Informative radio, educational radio. Interact now by emailing instructor@USAPrepares.com or text at 434-390-7953. Class, please take your seats. Now, your instructor, Vincent Finelli.
Everyone all set? Cocked? Locked? Here we go. Your dial set correctly to USA Prepares. Thank you for being in class today. 2 hours today, I'm going to be interviewed and by my dear friend of, a really long time. I think we're getting close to
not that
50.
long.
Yeah, we don't want to say it, do we? 50 years? We don't want to say that, do we? But yeah, Bert Bertonis. Welcome, Bert.
Hi, Ben. I'm on a cell phone. We had an office phone issue. I think it's worked out, but is the voice quality okay?
It's okay, but if you can get back to your office phone in California, Silicon Valley, during one of the breaks, that'd be a good thing to do.
Okay, first break.
Okay. All right. Where would you wanted to interview me about what?
Well, let's we got a bunch of callers last time. We were in the middle of discussing how to wire a home with really with everything. In fact, I think a good thing to pick up on is if you are building a home or I guess you could say renovating, a lot of people, tear down some walls and put up new ones. Let's revisit, because I think people might be amazed how many different cables that you really want to run through your studs in your home. And everyone thinks, it's, power and maybe one other thing. Probably more than 5 different cables if you really add them up, correct?
Yeah, at least in our house, that's correct. Mm-hmm. Do you want me to get into that, or do you want to? Yeah.
Well, let's just recap, because I think it's kind of interesting, and it's so much easier to do if you got the studs there and you're running them. I mean, for the cost of the cable, which is almost nothing, just run, all. I'm going to guess it's 6 or 7, all 6 or 7 of them everywhere. Would you agree with that?
Yeah, absolutely.
Yeah, so we got Romex, obviously. We can cross that one off. That's the obvious one, right? Your 120 volt power. So let's that's the obvious one. Okay, that's number one. What do you do next? What's the next most important piece of cable?
Well, here's what happened in our situation. So our house is about 1,300 feet from the road. And when we were building the house, we wanted telephone service. So the telephone company said, okay, well, you don't have the house built yet, so you guys have this 20-foot trailer you're living in. We had a camper trailer that was lent to us. So our son and I were living in this trailer while we were building this house. And so the telephone company ran across the field from the road this orange cable. And it with an orange sheath, so it's visible. And it has 4 conductors, and it's for telephone. So there's a red wire, a green wire, a yellow wire, and a black wire. Now, when they were done with that, and they ran permanent underground service from the road, 1,300 feet, to the telephone stanchion near the house, they didn't want that wire anymore. And they just throw it away. And I said, well, may I have it? If you're just going to throw it away, I'd love to keep that. And I used that. I used that 1,300 feet of wire to wire every room of the house. So what we have in the house is a box in every room, or at least one box in every room. And I'm talking about a 21 cubic inch blue plastic receptacle box. And it's mounted at the same height as wall outlets. And in that box is one of these orange cables. at least. Some have 2. And they're home run back to a punch-down block, which is a 50-pair punch-down block that the telephone company used to use back in the 50s, 60s, 70s, 80s, 90s, and so forth in commercial installations. You can buy them on, it's just called an RJ, I'll look it up. I think it's called a 66 block. You can find them on the internet, and you can use them to wire your house.
And Vince, I think that people know what you're talking about. If you ever gone in an equipment room at an office, you see them all over.
Mm-hmm. Right. And you can buy them for a few dollars because nobody wants them. So maybe $10, with shipping. At least that's what they used to be. And so we mounted that in a central location, and the telephone feed from the telephone company goes into that, and then connected to that box or that block in a star configuration, radiating out from that is connections to every single room. So what are these wires? Well, there's that orange wire that I told you that is telephone wire. And then there are 2 Cat 5e, category 5e, Ethernet cables going to the same location. And then there is going to the same location, cable TV cables too, for every single room. And, possibly, 1 or 2 other type cables. So for sure, there are Cat 5, 2. There are, let's say at least one of these orange telephone wires. That'd be 3. And then, probably a total of 5. 5 wires in each of these boxes. And so the idea is if we wanted to put, cameras, security cameras, we've got the cable TV cable. 2 of those. If we wanted to have, and it's in a star configuration, going back to one place. All these cables go back to one place. So if there's ever a failure, it's really easy to figure out because it goes from, let's say, the dining room back to the box, if you will, where all these cables show up. So that's how we wired our house for electronics, if you want to call it that, for
and
cameras.
Just to be clear, so no one's confused, the punch block, you were only using that for the phone line. You weren't trying to use that for the Ethernet or other cables.
Right. It's only designed for telephones. It does not support the bit per second rate of Ethernet. However, the way we wired our house, I have all of the Ethernet cables going to the same place. So the idea is if for example, let's say I wanted to have more telephone lines than 4 wires could support. A landline only requires 2 wires. So that orange cable that has the red and the green and the yellow and the black pairs, that can support 2 telephone lines. Now, if we wanted more telephone lines, we could use the Ethernet cable. It goes back from that same box, let's say in the dining room or the bedroom or the, kitchen, wherever. They're all over the house. It could go back and we could use the Ethernet cable for telephone. Or we could use the Ethernet cable for Ethernet. Or we could use the Ethernet cable for cameras because you could put a transformer on a wired camera, a security camera, and convert what would be coax to Ethernet and then convert it back at the other end of the cable. So the idea was flexibility. We knew what we wanted initially, but we thought things might change and we might want to use the coax for cameras. We might want to use the coax for television. But the interesting thing is we've never used the coax, the RG59 cable for television because we don't have television. We never installed it.
Yeah, well, honestly, Vince, I think in the future, if there's one of these cables that we're discussing that may go away in the future, it might be the coax because, technology is kind of moving to high-speed Ethernet. Let me bring up one other point because, on the Ethernet cables, they're a little bit unique in that you can't just connect them together or bridge them out. Did you put a high-speed Ethernet switch in the same location?
And let's define what a switch is. In class A, an Ethernet switch, you can call it a distribution point if you'd like. So what could happen is, let's say you have, router, a modem router that's connected to, whether it be a cable modem router or a twisted pair modem router, DSL kind of thing. The internet comes in on that, and then coming out of that modem router is an 8-pin connector. And that 8-pin connector is what you normally see on Ethernet cables. What we've done is we've connected our internet router to what's called a switch. And then into that switch, we have plugged all of our computers in the house. However, in some locations, it was more convenient for us to have multiple switches. So literally, in our house, we have 3 Ethernet switches, switching computer signals throughout the house. And they're all connected back to the same point.
Which is workable, but you do need, so the class understands, every time you put in an Ethernet switch, you do need to power it. So you need a AC receptacle someplace nearby to put in the power. But yes, you can cascade those switches. Some people like to put a big 16-port switch one location, or you could put a smaller switch, or really they're so low cost, keep it 16, but then just branch it out into 4-port switches at all different locations.
Mm-hmm. And what we have done is our switches are 10-100, meaning 10 megabits per second and 100 megabits per second. Now, those are not the fastest switches. Now we go way faster into the, gigabit per second.
Correct.
But these are plenty fast for us because, frankly, our cable only goes, the Ethernet Cat5e only goes 350 megabits per second. So our cable goes faster than our switch, and our switch goes as fast as the computers. So we're okay with this. And all our computers are old. They're probably over 10 years old, and that's plenty fast for us because we're not in any race, and we're not doing development work. I'm just doing some broadcasting and some research and that kind of thing. But we do have a home-based network, and the main switch, we'll call it level 1, the main switch that's connected to the Ethernet hub, the Ethernet modem router is 24 ports. And then connected to that are an 8-port and a 16-port switch. So that's what our network looks like. And we've got a lot of ports connected.
Vince, carrying on with cabling, I'll throw another one out. Did you put any, or did you think about any cables for security systems, for an alarm system? And I know you guys there's always someone at the Finelli residence, but for other people that may be more concerned about security, and let me say one other note, I'm a wireless guy, but I know a wired alarm is a lot more reliable. Did you put any cabling in for security purposes?
Well, let me share this with you. I don't want to get into specifics, but I'll tell you some of what we did. When we have a backhoe, and it's kind of a convenient thing. So when we use this, we can use this backhoe to trench. And when we were building our house, I looked at the property and I thought, where would I want to have cameras? Where would I want to have repeaters? Where would I want to have switches inside and outside the house? So we have underground cables all over the place in conduit, and those cables, we'll say it this way, those cables can support cameras all over the house. And in the barn, outside the barn, in the garage, we have a freestanding garage. We'll be right back. Bert Bertonis is with us, and he's interviewing me about how we wired the farm. The last thing we were talking about was security system. And so let me answer it this way. We have multiple buildings here at the farm. The farm is 241 acres. And to give you an idea of what that means, it's about, road frontage is 1 mile. So if you look at our fence, starting at one point going to the other end of the fence along the road, it's 1 mile long, literally. And at the deepest point, it's a half a mile. And at the shallowest point, it's a quarter of a mile. So roughly 1/3 of a mile deep on average and a mile long. And so there are lots of places we'd like to see. And because we built our own house, we could put in what we would like to have in terms of electrical wiring, in terms of AC, electricity, in terms of communications, etc. And what we've done is we put in things like cattle waterers. Now, a cattle waterer is a device that's plumbed underground with fresh water, and it's a trough that has, think of it like a toilet. The way a toilet fills up, it has a valve that determines how much water is in the back of the toilet tank. Well, there's a valve in this 300-gallon cattle waterer tank, and it maintains the level that we set it for. So the cows walk up to it, drink out of it, and if they drink 30 gallons each per day, it will refill immediately. Well, I wanted to know how the cows are doing without walking out there. So I ran underground cable to that cattle waterer, Cat 5 cable, and I can, and I'm not going to say whether I did or not, have a camera pointing at that cattle waterer. I could have a camera pointing at the garage, the back of the garage, the front of the garage, the side of the garage, in the barn, all directions around the barn, in front of the house, at the road, along the driveway, everywhere you can think of. So I just wanted to say that that's all possible. Now, it's a lot easier if you do it when you're building than if it's an afterthought. So the answer is yes. Security, cameras, all that, absolutely.
So, Vince, some people with smaller homes may be concerned about things like door sensors, window sensors, things like that. Usually that's just two-conductor. I know keypads can be four. Would you say that when you put in the multi-conductor cable, that would those cables with multi conductors in it could support that type of an alarm sensors as well? Absolutely.
And the way you can look at this is the alarm cable is cheap. It's the minimum insulation, minimum abrasion resistance, minimum everything, because it's designed for inside and it doesn't move around and doesn't get abraded. So it's relatively inexpensive alarm cable. I'm not talking about commercial alarm cable. I'm talking about home alarm cable. Well, what I did was I bought a security system, and I found one on the internet many years ago. And it was very inexpensive because it was probably pulled out of service from some location, or it was surplus from an installer that had a whole bunch of them and wanted to sell them. So I have the computer-controlled alarm system, and you can have motion sensors, you can have the window breakage sensors, you can have the sound sensors, you can have all that, and you can have the siren. Okay, very inexpensively. And the answer is absolutely, positively yes. You can use that same exact multi-conductor cable. And what we're talking about, class, is Cat 5e cable for the alarm system. Absolutely. And, you mentioned something, Bert, that I found quite interesting, and that was about the powering of the Ethernet switches for the computer network that we have. And yes, we have AC-powered Ethernet switches. But one of the things that we've done that's quite unique in our house is we have a whole house uninterruptible power system. And what we've done is we got one big UPS, uninterruptible power system, and we ran cables all over the house in a star configuration. Star meaning there's a point of origin and then you radiate outward from that rather than daisy chain. Daisy chain would be like a subway where you have stop after stop after stop, and if the track gets interrupted anywhere along the track, anywhere downstream is disabled. It's not like that. Ours is in a star configuration where one leg does not break the other legs. We'll be right back. Bert Bertonis is with us, and he's interviewing me about home wiring and the way we do it here at the farm in Missouri, the way you can do it if you'd like. Bert? Back to you, Bert.
Vince, do you have a doorbell?
Yeah, we do. And it's wired.
For most people, probably that's a dedicated wire. But in your case, at the Finelli residence with the multi-conductor, do you use that for your doorbell circuit?
I have a couple cables going to the doorbell. One is a 2-wire, which would be solid copper wire, red and white, and also Cat 5e. So the answer, I guess, is yes and yes. Mm-hmm.
Okay. And here's one. We touched on it the last time we were discussing it, but we didn't have time to get into it, that a lot of people maybe don't consider. But a low voltage circuit in parallel with your 120-volt Romex for what could be a variety of low voltage devices.
Okay, so here's what we've done. I bought some sheathed wiring or cable for alarms, and it comes in boxes of 500 feet. It's got a white sheath and a red and a black wire. And I've run that lots of places. So one of the things that we've done, and we're jumping all over with this, but one of the things that we've done is we have 12-volt wiring in our house as well. So, for example, I'll just give you one example of it. We have in our kitchen a wall switch, and it is an AC wall switch. Same kind of switch that you got in your house, class. Looks just like that. And it's in a blue plastic box in the wall. And this alarm cable goes into it from 12 volts. Think of it like a car battery. And it's connected to a regular wall switch. And when we flip that switch, we have LED strip lighting in the kitchen. We'll use that as an example. And the way we did that was we bought directly from China in the good old days. This is probably 5 years ago, or maybe even more. For $5 or $10, 15 feet of 12-volt LED strip lighting. And I mounted that on what you could call picture rail. Picture rail is it's like chair rail, except it's near the ceiling. And you would hang pictures on wires or cables or ribbons, paintings, that kind of thing. You see it in Europe. And so there is this picture rail running around the perimeter of the kitchen, about a foot down from the ceiling. The ceiling in the kitchen is 10 feet tall. And the 12-volt wiring is connected to the top of the picture rail with the strip LEDs facing upward. Now, these LEDs are on a copper base, flexible, that has 3M adhesive on it, and you can just stick it, peel off the backing, stick it on a piece of wood, like the picture rail, and it will stay in place for a while, okay? And ours points up at the ceiling. The ceiling is painted ceiling white, so we have indirect lighting, LED, in the kitchen. So what happens is when, let's say we have a typical power failure if you're connected to the grid, and this would apply to, a lot of people in class today. All you do is just turn on that switch and you've got lighting in the kitchen. Now, is it as bright as your other lighting? Probably not. But can you walk around and not bump into things? Absolutely. Could you serve meals? Absolutely. Could you eat it's way better than candles. It's way better than kerosene lights. It's way better than flashlights. It's probably 25% as bright as normal lighting. But once you turn it on, if you're in the dark and you turn it on, it's great. So we use it for night lights, and we have several different circuits of these in the kitchen. One is for a night light. It's just a small strip. It's in a bookcase, and it lights up the kitchen so you don't bump into things at night if you're walking around. The other is for lighting up the kitchen. And frankly, it is so nice that we leave it on almost all the time. Almost all the time. So how long do these LEDs last? I don't know, but I can tell you they last at least 5 years.
You use 12 volts or 24 volts for that, then?
12. Mm-hmm.
Okay.
And I did a quick calculation. So a truck battery, like a pickup truck battery, group 27, we'll call it car battery, lead acid battery. If you used it a few hours, let's say it was a grid down situation, and you wanted to have lighting for when it starts to get dark and you want to cook, and let's say 3 hours a night, it would last about a month with one charge on a car battery. Assuming the car battery is in good condition. So it uses very little electricity, very little current, very few watts. It provides a lot of light, and it lasts a really long time, and it's so inexpensive. So inexpensive.
Well, that's the thing with LED lighting, of course, for the class to understand is that LED lighting is immensely more efficient than your traditional tungsten AC light bulb.
Bert, of all the people I know, you were experimenting with LED lighting back in the 70s, way before most people even knew what it was. Way before. And,
well, remember I used LEDs as the tuning dial for the FM tuner that we used at our apartment in college days.
Yeah. Yep. Red LEDs. You bought them from a company called DigiKey, which was a wholesale surplus outlet. It was really neat. And, so class, Bert has been involved in electronics for a long time, almost all of his life. I would say, I'm guessing, starting maybe when you were 6 or 7 years old.
Yeah, I had I was lucky enough to have a dad and an uncle both involved in electronics. But by the way, interesting side note, it's pretty much frowned upon to use red LEDs now for anything except warning devices. That's kind of an international convention. Of course, back then, that's about all we could get was red LEDs. But,
right.
They're available now in every color.
I don't know if blue was available back then. I don't remember blue, but I do remember white was more difficult to get. And it was kind of you could only get really bright white. And, back then, no one really knew how long LEDs would even last.
Yeah, and they didn't last long. That's, I was an early adopter with LED home lighting, and it certainly was very efficient. But I'm talking like between 5 and 10 years ago, the reliability was awful. I mean, I'm talking about in some cases like 1 week lifetime. They quote, 50,000 hours, whatever. Well, that pretty much was the term, and it still was probably worth it in many cases because you save so much on electricity because, most LEDs are somewhere around 80 to 90% efficient, in terms of, electricity to light, whereas your traditional light bulb is like 5 to 10% efficient. Most people don't realize it's primarily a heat generator.
That's exactly right. And, Bert, I've experimented. I have a lab grade variable power supply, the kind that you would use in an engineering lab. I bought it on eBay, probably for $35, something like that, shipped. And it's made in Japan, and it's probably 30 years old, 20 years old, but it's got meters, not a digital display. It's got analog meters. And I can control the current and I can control the voltage. So I was experimenting with these LED strips. And what I found out was, let's say on a scale of, 1 to 100, 100 being maximum brightness. If you turn on the LEDs, if you provide them with, let's say they're rated for 12 volts. If you provide them with 10 volts, they use very little current. If you provide them with a little bit more, like 10.5 volts, they use more current. If you provide them with 11 volts, the current that they start to consume increases at an increasing rate. And when you get close to 12 volts, they can consume like 3, 4, 5 times as much current, as much electricity as they would at a lower voltage. Can you explain why that is?
Yeah, and first of all, the actual LED voltage is typically a lot lower. The circuit is usually a resistor in series with the LED because most LEDs would blow out if you put 12 volts across one. So for the class, if you are going to experiment, I would always put a series resistor in there. But, there's a big difference between how a light bulb works and an LED works in terms of efficiency. So an LED will certainly get brighter and brighter as you put more and more current into it, up to a point, but its lifetime goes down. And that partly explains why the early light bulbs had such a short shelf life, is LEDs were expensive, so the manufacturers would try to juice them up to high current, get more lumens out of them, but that shortened the life. The efficiency of the LED also goes down as you start really maxing them out. The interesting thing is a regular light bulb, it's almost the opposite. I mean, it's not a easy thing to compare because it's two completely different technologies, but a low wattage light bulb might only be 5% efficient, and a 100 watt or 150 watt tungsten light bulb may be somewhere between 10 and 20% efficient. So the efficiency of tungsten actually goes up when you get hotter and hotter. That said, they're all way inefficient and, as I said, heat generators. But in terms of LEDs, you're actually better off, if you care about lifespan, giving them less current, and they truly could last 50,000 hours if you give them a small nominal current.
Yes, and those 12-volt lighting strips that we've been talking about actually have four LEDs in series. So there's a 3-volt, a 3-volt, a 3-volt, and a 3-volt, all in series. So if you add up 3, 3, 3, and 3,
yeah,
you get 12 volts.
That's
and that's
enough.
why,
okay, so that would get to 12. But
right.
I would admonish anyone to put 12 volts across a raw LED without a resistor. It's almost certainly going to pop.
Right, instantaneously.
Yeah.
That's absolutely correct. So, class, what I'm saying is these are designed to be run on 12 volts. And they work really, really, really well. I've proven it here at the farm, for, use in the kitchen and other locations. So, yes, you can. And I suggest that you use a fuse with that. And when you buy these LED lighting strips, it'll tell you how many watts that, it will consume per foot or per meter. You then multiply that times the number of meters or feet that you have of strip, and then you can convert that to how big the fuse should be. But fuse all of this. We'll be right back.
Okay, welcome back, class. This is Bert Bertonis, and we are interviewing Vince Finelli today, this morning. Welcome, Vince.
Well, thank you. Thank you, Bert. Where do you want to go?
So just to recap, we discussed home wiring. I added up 7 different distinct wiring circuits. Now, some of those were combined on your multi-conductor that you run, but interestingly, I kept a note here as we were discussing it, and we had 7 different cabling through the home. I don't think most people would have guessed that there's a need for that many. So, let's...
Okay, we did, and there's some others. We have sub-panels which use 100 amp cable as well, so we can add one more to that.
Is that for 220?
Well, yeah, it's for 220. The way we wired our house is, well, I have to step back. Our son was homeschooled at the time. He was about 15 years old, and he and I were building this house. Mrs. Finelli and the rest of the family was in Virginia, and he and I were living in this 20-foot camper trailer while we were building the house. And it took 18 months to get it, covered, roof and the stone on the sides. I mean, it took a long time to build this house. So we had a lot of time to think about what we wanted and where we wanted. And what I did was as part of his classwork, because I was teaching him as a homeschool teacher, it was just the two of us, I gave him the task, and I said, well, here's how much wire costs. Romex, 12-2 with ground, the standard yellow jacketed Romex. Here's how much it costs. We paid $168 for 1,000 feet. It went up to about $468 during that time because there was a major storm and hurricane, and it just consumed all the wire, consumed all the plywood and OSB sheathing as well. So the prices just jumped, just skyrocketed. So what I said to him was, all right, here's how much it costs per foot for 1,000 feet of Romex, 16.8 cents per foot. And here's how much it costs for, and that's 20 amp wire. Here's how much it costs for a 100 amp sub panel. Here's how much the breakers cost each, about $3.47 each. And here's how much 100 amp service cable costs per foot, which is a little more expensive. It's aluminum, and it's used for more amperage, heavy loads. And I said, so here are the circuits, here are the plans, here's how much wire, here are the rooms, here's where we're going to put the outlets. What do we do? Do we run home runs with 20 amp Romex, or do we put some sub panels in?
Yeah,
And
I have sub panels in my home as well. Did you use 6 gauge for that?
We used 1 gauge, 1 aught,
1 gauge.
1 0.
Wow. That's you're joking, right?
No.
1 gauge. I wouldn't, to be honest with you. I don't think most people would know how to even connect to that. The copper's thick.
Well, it's very thick. It's very thick, and it's not all that flexible. And here's why: because you could get by with 2 gauge for 100 amps if you're only going 20 feet. But one of the runs from we'll call it the main panel. We'll call it the main panel where everything comes off in a star configuration. It's about 88 cable feet. So because of that, and because of the potential voltage drop, we went with the next gauge larger, which is 1 gauge. Now here's a way of thinking about this. You've been to our home, and maybe I don't want to say exactly what it's like, but if you've watched Combat Class, and I know Bert is one of your favorite television series as well as mine from the 1960s with Vic Morrow and Rick Jason. Yeah. If you see the farmhouses, this was set in France, World War II France. If you look at the farmhouses and the style of those houses, that is exactly what we have. We have a French style, probably a 200, 300-year-old design farmhouse. Okay.
Yeah, then there's one difference between the homes in Combat in France. Some of those homes were missing roofs and walls.
That's right. And the Germans were the ones who did that. And we helped also a little bit, but we blew up some and they blew up a bunch. But yes, so the style is that of the French farmhouse. However, our house would be like 3 of those stuck together, right angles to each other. So literally, if you got a big saw and you sawed through some walls, you could separate our house into 3 small farmhouses. And the reason that we use some of these sub panels and have so many sub panels is I thought, our house was designed as a multi-generation house.
Okay, Vince, we got to go. When we come back, can we move into solar power, get a little more high-tech?
Yeah.
Okay, sounds great. Hour 2.
I just wanted to mention that because we have sectional housing, like 3 separate houses all stuck together, each one has a sub panel for future whatever we want to do. We could divide it into 3 houses or leave it the way it is. So that's why we did it that way. All right. We'll be right back. Bert Bertonis is interviewing me, and we're going to be talking about solar. I think he's got some questions about how we did that. We'll be back.
Hello, class. This is Bert Bertonis, and I am interviewing Vince this morning, and we are discussing topics related to home wiring, home security, and this hour we're going to be discussing a topic I know a lot of people ask about, solar power. Vince, how are we doing?
Yeah, okay. What can I answer about solar power? We built one, and we built our own. So we did not have it installed by anybody else. We did it from top to bottom ourselves. Where would you like to go with this? Do you have any specific questions? Size, difficulty, cost?
Sure, and that's good that you built it yourself because, you know what? That makes you an expert, almost an instructor. So, Vince, what are the first considerations in planning? I know people are thinking, how many panels, how many watts? Do I want it to replace my home wiring? Do I want it just for emergencies or something in between? What are the first planning steps and considerations a homeowner might consider?
Well, there's several things that need to be done. Number one is you need to figure out how much electricity you need, not want, but need. That's the starting point. And the way to do that is kind of simple, but it'll take a weekend, and at least, and in terms of elapsed time. There's a device called a kill-a-watt. Kill-a-watt. You can buy them on eBay. And what it is a plug-in meter. You plug it into your wall outlet. And then it has a receptacle that you can plug a device into. So, for example, let's say you decide that you want to have a microwave oven running on your solar system. How much electricity does that consume in terms of watts? Well, you plug your kilowatt into your wall outlet, you plug your microwave oven into your kilowatt, and it'll tell you. You fire up that microwave oven with something in it to cook, and it'll tell you how many watts it is. And it might be 1,300, 1,400 watts. And that's a good starting point. And then you look at your refrigerator. How much electricity does that consume? And then you look at, let's say you have a freezer. Now, we have multiple freezers here at the farm, and they consume between, let's say 150 watts running and 250 watts running. Now, when they start up, they consume more than that. When that compressor fires up, it consumes, let's say, 2 to 3 times the watts that it takes to just run it once the compressor gets running. How long does it take to get running? About a second or two. So you have this list. You look at your lighting and you say, well, that's a LED light and it's 9 watts. And we've got, let's say, you have 3 of them in the kitchen or 5 of them in the kitchen, and you write on a piece of paper, kitchen lighting, 9 watts times 3 or times 5 equals, whatever it equals. Then you look at your refrigerator and you look at your freezer and you look at, let's say, your microwave oven, but that's not on all the time. And you look at what the total consumption is, and you look at when you are using these devices. So, for example, if you're using your microwave oven during the day and it's sunny out, you probably will have a system that might be able to power that. But at night, when you're running, let's say, on your battery bank, you might want to be a little more cautious. So you might want to shift the usage of your devices to when the sun is shining. And that's what we do here at our house. So, for example, Mrs. Finelli will look at we have a meter in the kitchen that tells us how many watts the system is producing. It tells us how many watts we are consuming, and it tells us the delta. So whether we are drawing from the battery bank or whether we are charging the battery bank. And so she has switches. I built a switch box, and we can talk about that if you want, out of common, ordinary parts that you can get at any big box store. You can buy them on the internet. I did. And they're called 3-way switches. And so we have in our kitchen 6 3-way switches. And I know I'm jumping around, but there's a reason for all this. So, for example, we may not have enough electricity in our battery bank to run the dishwasher at night, but it may be real sunny during the day. So we can flip the switch to either solar or grid. And we may say, well, let's use the grid for the dishwashing right now. Or it's really sunny, let's use the solar system for washing the dishes, or the washing machine, the clothes washing machine. So what you need to do is figure out how many watts each one of these devices takes and when you're going to use them. And then you think about a couple other things. One is, can you have a solar system? Well, I'm not big on rules and regulations, but there's some places that say you just can't have solar panels, deed restrictions, those kinds of things in neighborhoods. You have to have a good, unobstructed view of the South, at least in North America you do. And you need to have it at an angle that, and if you want to know what that angle is, that salute that was used by our enemy in World War II in Germany, those guys, they would have this salute their arm would go up, let's say, 35 degrees. Well, aim at the south, use a compass, find out exactly to the degree where south is, and you aim that way. And if you raise your hand as they did in that salute during World War II, that will tell you about where you need to aim your solar panels, at that angle. Now, the reason for that is that's the most efficient angle to absorb the sun's rays to generate electricity with the solar panels. Here in our part of the world, it's about 37 degrees. So we have our panels aimed exactly the way I said. And during sunny days, and we might get 5 or 6 hours of sun, and we're generating electricity. So early in the morning, we start generating electricity, and as it gets closer and closer to noon, where the sun is at its maximum point for the day, that's when we generate most electricity, and then it wanes off as we get toward evening. So let's say around 9 o'clock in the morning, we start generating electricity, and around 5 o'clock or so, we are not generating much electricity. But during the height of the day, the middle part of the day, we're generating the most electricity. So you need to figure out those things.
Since that angle is a trade-off, correct? Because obviously in the morning and evening hours, the sun is much closer to the horizon, and in a lot of latitudes during the summer, the sun might be almost totally vertical. In Hawaii, it would be totally vertical in June or July.
Those are very good points that you're bringing up. So you're absolutely correct. And what we have done is we optimized for what we thought would be the most durable while generating the most voltage, while being the most resistant to tornadoes, because we have tornadoes here. And sometimes we have hail. Now, if you have your panels at a steeper angle and hail is coming down, it's less likely to break the glass of the solar panels if they are steeper than if they are flatter. That's one thing. Another thing is, if it snows a lot and your panels get covered with snow, you're not generating any electricity. Now, if you put them on the roof, are you able to get the snow off them? Is your roof angle one that would encourage the snow to stick on the solar panels? So putting them on the roof is a great idea, except if you want to service them.
Sorry, Vince, I was going to ask you real quick, are there de-icing circuits in any solar panels for the colder climate?
I don't know. I have not investigated that. We don't have any of those. But I can tell you this, that solar panels, when the sun shines on them, when they are generating electricity, let's say there's a sheet of ice, but it's translucent, you'll still be able to generate some electricity. Okay?
Sure.
And as it generates electricity, the panels get warmer. And I believe that, well, the angle that we have is semi-steep. The ice will just slide right off. It'll melt.
So that's the self-de-icing
yes.
effect.
Uh-huh. Right. And so what we did was a combination of, well, let's look at it this way. In the summertime, as you were mentioning, the sun is stronger. So there's plenty of electricity in the summer, but there's not plenty of electricity right now in the wintertime. So we optimized our system where we point the panels for the wintertime, not for the summertime.
And I'm guessing you don't use electric heat, therefore, at the Finelli residence.
Right. Well, the answer is, I guess, in most, yes. However, and there's several types of systems. There's 3 types, and I'll tell you that in a second. So, for example, we heat our house with wood. We have a wood furnace, and one day we can go into how those things work. So we have an outdoor wood furnace. Now, this thing is the size of a storage shed, small storage shed. It has a firebox that you could literally climb into. It's roughly 60 by 48, so 4 feet by 5 feet in terms of the size of the inside dimensions of the firebox. So it's pretty big. And that burns wood. It heats a tank of water that surrounds the firebox on all sides except the front. And that tank of water is then circulated underground through plumbing, insulated plumbing, that we put in to the house, and we have a heat exchanger in the house, actually multiple heat exchangers, and it extracts the heat from the hot water and heats our domestic hot water like a hot water heater, but our hot water heater is heated with wood from this outdoor wood furnace. And we have ducted heating, hot air heating, which goes through other heat exchangers. So warm air is blown throughout the house from the heat exchangers that are warmed up with the water that circulates from the wood stove. To make a long story short, we consume between 75 and 100 watts of electricity 24 hours a day, 365 days a year to run the circulator pump to pump hot water from the outdoor wood furnace to the house.
You know, the first locomotives used wood before they switched to coal.
Mm-hmm. And, you know, it falls down. We have lots of acres of trees, and the limbs fall down, the trees die naturally, and we go drag them out of the woods with the tractor, cut them up, stack them, and then burn them a year later. So our heat is almost free. Now, we also buy wood. There are places where we can buy wood that nobody wants. Nobody wants it. It's left over from fabrication of, you know, wood products. Nobody wants this, and we can go with our trailer and we can pick up enough wood to heat our house for $100 a year.
So with that trailer, could you design a automobile that burnt wood and you just keep it in the trailer and throw it in?
Absolutely. As a matter of fact, in Combat, that series that I've been assigning as homework, you will see in France, they had trucks that had a fire on the side, and what would happen is they burn wood on the side of the truck by the engine, and the exhaust from the wood burning fire on the side of the truck, that was part of the truck, that smoke would be pulled into the carburetor, if you will, and consumed as fuel.
Hello, class. This is Bert Bertonis, and we are interviewing Vince this morning. And Vince, let's pick up again on solar power. I noticed you said you put in a three-way switch, the switch between solar and grid. Now, that's something most systems don't have. Is that correct?
That's correct. And let me just share this thought with the class. There are three basic types of solar systems. One is off-grid. Off-grid means, like, let's say you're in the mountains and there's no electricity coming in from the utility company. It's totally off-grid. You do everything. So you have your own battery bank, you have your own solar panels, you have an inverter, charge controller, etc. There's another kind called grid tied. Grid tied, meaning that you are connected to the grid. The way that works is you do not have a battery bank. Your solar panels collect electricity from the sun, or collect solar rays, convert it to electricity, and you have an inverter that sends electricity to the grid. So the grid acts like your battery bank. You send it out there, and if you need it, you get it back. And you can send it out while you're getting it back simultaneously. And there is an accounting system, a metering system, that determines how much you're sending out and how much you're drawing from the grid. And it works really well, except if the grid goes down, because the grid is the clock. The grid is the clock for the system. So if your grid goes down, even though you have an inverter, even though you have solar panels, even though you have everything except batteries, if the grid goes down, you have no electricity, none. And then there's the type we have, which is a combination. It's an on-grid, grid-tied, off-grid, hybrid system. So what we do is, if we want to be off-grid, no problem. If we want, throw a switch. If we want to be on-grid, that switch controls whether on-grid, off-grid. We can disconnect from the grid at a moment's notice, at a second's notice, literally. And if in the wintertime we need more electricity than we can generate and store, we could use our generator. And we could charge our battery bank with that, and some people do. Rich Sheben does that. However, it is less expensive for us to use the grid for supplemental electricity until we put the rest of our solar panels up. So we only have about a third of our solar panels up. We have them, and we just need to fabricate the array, the bracketry, the supports, etc., the frame to put the rest of the panels up and wire them. We have everything we need to do it. We just haven't finished it yet. So to answer your question about this switch, it's really neat. Class, you've seen these switches in hallways. So if you have a hallway and at one end of the hallway you have a light switch, at the other end of the hallway you have a light switch, another light switch. And if you're at either end of the hallway and you want to turn the light on, you flip the switch. And if you want to turn it off, you can turn it off from that same switch, or you can turn it off from the switch at the other end of the hallway. They're called three-way switches. I don't know why they're called three-way switches, but they have only two poles. And so the way to look at this is the switch is either on in the up position electrically, or it's on in the down position. So we took that very simple switch, and you can buy them for $2, literally $2 each. And we have it wired into our electrical panel so that and we figure up is solar because the sun is up, from it's overhead. And down is the grid because our grid comes in underground. We have underground, we don't have power poles on our farm. It's all underground wiring because we insisted that it be done that way. So we have these switches. There's 6 of them in a box in the kitchen. So there's a six position box. It's actually 6 one-gang wall boxes all connected together, and they're called gangable, G-A-N-G-A-B-L-E. They're metal boxes, and you take out one screw and a side plate removes, and then you can attach 2 of them, 3 of them, 4 of them, 5 of them, 6 of them, as many as you want, and you can gang them in as many boxes as you want, and we ganged 6 of them together because the largest wall plate that you can get typically is 6 positions, 6 switches in one wall plate. So we have 6 switches in the kitchen, and they control things like the garage lighting, which is 7 fluorescent tubes, 8 feet long each. So that's 7 times 2 tubes, that's 14 tubes at 100 watts apiece. So 1,400 watts. That's a lot of load.
And welcome back, class. We're discussing solar power today.
Okay, so Bert, I wanted to mention that these switches are really common. They're called three-way switches in if you use the vernacular of the electrical department box store. They're called three-way switches. I use 20 amp switches.
Yeah. Now, Vince, the way you use those switches in your solar system, the switch is exactly the same, but the circuit is different because in a three-way lighting scenario, every time you flip the switch, it alternates with up being on or down being on. It's a clever wiring scheme, whereas in your case, you're using it simply as a A-B switch to switch between solar and grid, correct?
That's exactly correct. And there are 2 different grades for most of us to buy. One would be called, the standard 15 amp switch that most of us have on our wall switches. And we have those 15 amp ones. Those are the ones that cost less than 40 cents a piece. You buy 10 of them for $4 at, it's called a contractor pack at Lowe's or Home Depot or the big box stores. But the ones that I use for this particular application are called spec grade, S-P-E-C, as in specification. And they're marked spec, S-P-E-C, on the switch. They're 20 amp. They're a heavier duty switch. So instead of costing, around $1 or less, maybe 40 cents for the 15 amp version, these are three-way. So they're about $1 a piece for the cheap ones. But the better ones, the spec grade, are about $2 a piece. And that's what I use because I wanted the 20 amp contact rating of these particular switches. And it's really simple. I've got wire coming in that's from the grid for each switch and wire coming in from the solar system. So I've got a breaker on the grid side and I've got a circuit breaker on the solar side. They come into this electrical box in the kitchen, and I can switch between the solar and the grid. And the outgoing component of the switch goes to the circuit. Now, I'll tell you what the circuits are. So of these 6, I was concerned that we might not have electricity enough generated from the sun to power these following devices. So I picked the 6 that I thought were important. And they are the lighting in our automotive shop. There are 7 fluorescent lights, 8-foot tubes, 2 tubes per light. So that's 1,400 watts. Each one of them is roughly 100 watts. So that's 1,400 watts. That's a major consumer of electricity in our farm. Then the next one would be the washing machine, the clothes washing machine. Next one is the dishwasher. Dishwasher has a heating element, so it wants to make sure the water is warm enough to dissolve the detergent to wash the dishes. The next one we have, and maybe we can talk about this if we have more time sometime, is electrical code. So electrical code wants you to have roughly 1 outlet every 2 feet on the kitchen counter. Okay. Well, one of our outlets is switched with the switch. And the idea is we may not have enough electricity to bake bread from our battery bank. So we may want to switch it to the grid. The other one is the kitchen lighting. We may want to use the grid or the solar system for the kitchen lighting, which is about roughly 15 can lights, 15 in the kitchen. And then the microwave oven / range hood. So instead of buying a range hood, I bought a microwave oven with a range hood to vent outward, because I was able to get a microwave oven and range hood combination for less money than just a range hood. So I stuck one of those over the kitchen stove. So those are the 6 switches, but that's not enough. I bought more. I bought another 10-pack of these 20 amp spec grade switches in the boxes and the stainless steel cover plate, and I'm going to add them in as well, because I want to put the freezers on this switching system as well as the outdoor wood furnace circulating pump and other circuits. So that's what we've done, Bert, and I have never seen a house that has that ever. But it's easy to do, and you can do it for $100. Yes.
Vince, I'm guessing that you use the screw terminals on all your switches. You don't use the push-in connectors for the Romex.
Right. That's exactly correct. And the reason for that, class, is if you look at these switches that you can buy, they have these little holes in the back and also the receptacles. And you can just strip the wire and stick the wire in. And a lot of electricians do that, which is absolutely beyond crazy to me, because those spring terminals get weak over time. There's a very small contact surface area where the wire that you've stripped to push into this switch or this receptacle contacts this spring type connection. It gets hot over time. It weakens the spring. As the spring gets weaker, the connection gets weaker. It starts to arc and it can cause a fire. It is the dumbest thing I've ever seen. So we always wrap around the screws on the receptacles and switches, and you always wrap it in the clockwise direction. So you make what looks like a shepherd's hook. It is almost almost a 360 degree circle of wire that fits tightly around the screw. And there are special pliers that are made for doing this. And that's what I have. And I wrap it tightly, screw it on very tightly with a flat screwdriver, because you can't get enough torque with a Phillips screwdriver on these. So that's how I do it. You're absolutely right, Bert.
And you could use a long nose for that, correct?
Yes, kind of a heavy. You wouldn't want to use a delicate, like a jeweler's long nose. You'd want to have they're called needle nose sometimes. Yes, you can. But what I have is a pair of pliers that's made for Bell Laboratories. When it used to be Bell Laboratories, it's stamped Bell Laboratories. You can buy them on eBay. They have a kind of a greenish handle, and they are a short needle nose, narrow needle nose with cuts in the end of them where it grips the wire so the wire won't slip off. They are perfect for this application. They'll probably cost $15 for a 30-year-old used pair or 40-year-old used pair. That's what I have.
And Vince, who was the original founder of Bell Laboratories?
Well, I don't. Well, maybe it was. Certainly, it's tied to Alexander Graham Bell, but
yeah.
Schottky was one of the guys who invented the transistor. And my dad, when he was a principal, had Schottky's son in his class.
Wow, interesting. Was that in New Jersey?
He was principal there, yes. Uh-huh.
So, you just opened up something for another show.
Uh-huh.
Schottky had a company called Schottky Labs, and apparently, although he hired brilliant engineers, everybody hated working for him, and Fairchild Camera and Instrument Company on Long Island got very entrepreneurial and stole away some of the Schottky employees, formed Fairchild Semiconductor, and moved it out to California.
And I know you're very well familiar with Fairchild and National Semiconductor.
Well, then Fairchild gave birth to virtually all of the semiconductor industry in Silicon Valley, and that includes companies like Advanced Micro Devices, who now is the leader in graphics chips, and National Semiconductor, where I worked for a while briefly, who has now been bought up by Texas Instruments. TI, of course, also being a pioneer in semiconductors from Texas. They say that both TI and Fairchild both share kind of the invention of the integrated circuit back in the 60s.
Mm-hmm.
Okay. So very interesting. Moving along. So anything else on three-way switches?
No, it's a really great way to go. I have a warning for the class. If you decide to build one of these, you can look up how three-way switches work. And literally, you might also refer to them as a single-pole double throw, abbreviated SPDT, single-pole double throw. I would recommend, if you're going to build one of these, that you use the 20-amp switch called the spec grade, as in specification. I happen to like Cooper brand. I think they're really, really good. I don't like Hubbell. Hubbell used to be a fabulous manufacturer. Now they come from, the kind that you'd be buying will be coming from China. I'd rather buy them from Mexico, and that's where Coopers come from. They're also known as Eaton, E-A-T-O-N. I don't know if Eaton bought Cooper or what, but I really like the Cooper/Eaton switches, and that's what we've standardized on here on our farm. But here is the caution. Let's say you are running a heavy load. Let's say now you can run 1800 watts on a 20 amp circuit, because the way it works is you should not load an electrical circuit more than 80% of its maximum capacity. So a 20 amp circuit would be 20 amps times 120 volts, or 2,400 watts, 2,400 watts. So if you run it at 1,800 watts, you're good. Well, we're running about 1,400 watts in our garage. And if I were to switch from grid to solar, or from solar to grid, while those lights are on, I can cause an arc and cause the switch to burn up. So you don't want to switch them when there's a hot load. You want to make sure that you power off the load, then move the switch, okay? Because they're not designed for hot switching. Simply the separation of the contacts isn't great enough. So that's how that works. So those are my thoughts on the AB switch, or the single pole double throw switches, or the three-way switches, as they're all referred to.
Okay, so Vince, you put your solar in after you built your roof, correct?
Correct.
So I'm going to guess it's a lot easier if somebody's building their house to plan for solar from day one.
Yeah, and here's some thoughts about that. As I mentioned, the solar panels get warm, and the roof gets warm. Most people do not have a white roof. And I've measured the temperature of our roof, and it'll go 150 degrees easily. Now, we have a roof that would be colored like the color of bark on a hardwood oak tree. Okay, so It's called weathered wood. That's the color of our composition shingles on the roof of our house. Well, at 150 degrees, that's pretty hot as a starting point. So the solar panels get hot themselves because they're like a bluish, blue color. And just even when they're not generating electricity, they get warm. Well, if they're on the roof, how much distance is there between the roof and the back of the solar panel? Not too much, right? Because most people want them close to the surface of the roof. So now you don't get cooling. Air can get underneath there, and is the air hot or cool? Well, the solar panels run hotter on the roof, and I don't want that. So I have ours on the ground. If they get snow on them, ice on them, I can take a broom and I can sweep them off, even though they're about 14 feet tall. So I like them on the ground where I can maintain them better. But yeah, you're right. We'll be right back, right?
Yep, interesting. Welcome back, class. We're with Vince Finelli talking about home solar power.
You know, Bert, there's one thing that we were talking about that I probably should address. You mentioned solar panels on the roof, and I delineated a couple of reasons why. One, your roof angle may not be suitable. It may be not steep enough. It may be too steep. It may be facing in the wrong direction. It may be east and west rather than south. And there's another reason. Well, several reasons. One is when the roof is designed, it's designed for, let's say, a snow load. If you live in a snowy area in California, there's not much snow, so roofs tend to be flatter. In Florida, they tend to be flatter. And depending on the roof construction, you may not have the support that is required for the added weight of the solar panels. The other thing is, if you have them installed and someone does it for you, you got guys walking around on the roof, and they've got their boots on, they're going to tear up the roof if it's a composition shingle roof. There's no way around it. And then when they mount these supports to your roof, to support the solar panels, the rack, if you will, they're going to drill through the shingles. And it's just another place for a leak. And when you were here, you noticed that we have a gas log fireplace, but we don't have a chimney. The house plans call for 2 chimneys, but we don't have them because a chimney is a great place for water to come through the point where the flashing of the chimney meets the shingles. So we don't have holes in our roof for those reasons. We only have 3 holes in our roof. One, and is for one purpose, and that is the vent pipe for the plumbing system. That's it. There are 3 of those, and I put in the minimum that would let the plumbing drain downward, and that's it. So, because I don't want leaks in the roof. So those are the reasons why we use the ground mount for the solar panels. There's something else that I should probably mention, and you can buy an adjustable solar mount. So if you want to optimize for the winter, you can tilt the angle of the solar panels for that. If you want to optimize for the summer or those months in between, you can adjust solar panels so that, and some of them, if they have an adjustable rack, for that reason. However, where we are, I chose not to do that because we live in Tornado Alley, and there is no adjustable solar rack I've seen that can sustain the wind loads that we have. We have gusts like 70 miles an hour or higher here. And ours have stood up to 70 mile an hour winds. I know that for a fact because we were here when it happened, and the rack is just fine. So we built our own rack, Bert, out of used shelving material that came from like a Home Depot, the lumber rack shelving, those pallet racks that will hold these massive loads of pallets of wood, like plywood and 4x4s and 6x6s. Those racks that you see, they're really heavy. We used those. We bought them used and cut them and fabricated them and welded them and designed the angle and the system ourselves. And we mounted them on piers that we sunk into the ground of concrete. We had bought what's called sono tubes, SONO tubes, and they're cardboard tubes, and you've seen them at lampposts and parking lots. And they have, what you do is you dig a hole we used an auger, dug a 12-inch hole into the ground, 3 feet deep, put the sonotube, so it went just below the ground level, and it's plumb, it's vertical, it's perfect in terms of being flat and level and all that, and it's square, and we sunk them in the ground, filled them with concrete and rebar, let them cure for a month, and then we bolted the rack on top of these concrete piers. So that's how we did it, and it works great. And it was probably 1/3 at the most of the cost of buying a rack. At the most, 1/3.
Oh, very interesting. Is there anyone installing solar who can do that for listeners for class that might be considering a solar project like this? Are there contractors that can do that?
I don't know. I don't know of any contractor that would go through the lengths that we went through to build ours, to do it the way we would do it. A contractor would use some kind of a kit, and it would be nowhere near as durable, nowhere near as inexpensive, nowhere near as good looking as, I would be delighted to put an image or images of our system up on the internet so people could see them. There's nothing like it. You go all over the internet, you look at images of solar systems. There's nothing like ours. And I would do it, except that the trolls have given me such a hard time that I took our website down. So I can't do it, or I won't do it, because of that reason. But it is quite different in terms of durability, aesthetics, and delivery of electricity. It's pretty good.
Okay, well, thank you, Vince. It's been an enjoyable 2 hours.
Hey, well, Bert, thank you for interviewing me, and thank you for asking these questions. And if you've got more, we just got to the tip of the iceberg, didn't we? I mean, there's so much more in depth we could go if that's what you would like to do. So,
well, let's see what feedback we get from class.